In this video, we're going to look at one of the most important parts of programming, and that is handling errors and debugging your Python code. So by the end of the video, you'll know how to prevent your programs from crashing and easily fix problems that come up or that pop up when you're writing your code. So first, what exactly is an error? Think of it this way: an error is something unexpected that happens in your program that, in this case, Python doesn't know how to handle. So whenever something happens unexpected in your program and Python doesn't know how to handle it, that automatically gets logged as an error. And there are two main types of errors that you should know about. We have syntax errors and we have runtime errors. I'll just write here as a comment. We have syntax and runtime errors. And there's a major difference between the two. Syntax errors, these are mistakes that happen in the structure of your code. So think of when you make a typo or you're missing colons, etc. Ideally, this syntax errors happen when you don't follow the conventions that you're supposed to follow in writing your Python code. The same way in any language when you're learning, for example, in English, you have to sort of start a sentence with a capital letter. You have to end the sentence with a full stop. Such kind of rules that you have to follow. Python, of course, also has those rules in form of in its syntax. And whenever you don't follow these rules, you write or you make an error in the syntax. That's when you come up with a syntax error. Then you also have these runtime errors. Runtime errors, this is whereby your code structure is fine, but something goes wrong when you run the program. For example, you divide a number by zero, right? When you're writing the syntax, you'll write it correctly, but whenever you divide a number by zero, that is bound to bring an error. So that error happens during runtime. Ideally, the error happens when your code is being executed. It notices the error and then it pops up as a runtime error. So let's look at just simple examples of these errors. An example of, let's start with the syntax error. I'll actually just do this right below the comment. This is how a syntax error would look like. For example, you write a print statement, then you write a statement like hello. Let's say you write hello world, and okay, let's do it this way. So you have your statement, it's a string, you have everything correctly there, but you don't have the closing parentheses. That is a syntax error. And just to confirm that, let's run our code. We'll say python 3. I called this file error underscore handling.py. So we type in that. Then when you run, you see we get a syntax error. And it tells us this is a syntax error. And then it says that this opening parenthesis was never closed. Again, this is the good thing about these errors. Most of them, you always get a statement that is descriptive enough to tell you what the error was and a suggestion of something that might have gone wrong. So right now, if I go ahead and add a closing parenthesis there, okay, I need to just increase the font a little bit. So if I add the closing parentheses right there, then the error is gone. So if I run the code again, now you see our code is running, right? So again, don't mind this underline. It's taking some time to connect. Okay, so that we've seen what a syntax error looks like. Then let's talk about a runtime error now. Like you've mentioned, a runtime error, this is whereby your code structure is still fine, but something goes wrong when you run the program, like dividing by zero. So let's try dividing by zero. Let's say you have a variable x, and this is where we're storing the resultant of this operation, that is 5 divided by 0. So I'll just add some space here for readability purposes. And if we run our code here, you see we get okay, the first line gets executed because we've already solved that, but now we get this is a runtime error now. And the runtime error that we're getting is a zero division error. So it's telling us here dividing by 0. And once you see that, one of the instincts that comes up, of course, is for you to solve this error, what you need to do is just divide by a different number, not 0 maybe. So you'll do like, divide by 1. Then when you do that, you run your code runs perfectly. So these are the kinds of errors that you get. But I'm going to just maintain the 0 here and comment it out, and also do this and comment it out, so that when you are going through the code, you will understand what was happening at that point. So without handling these errors, like you've seen, your program can crash, and we've also seen that it just crashes immediately, actually. So this is where Python gives us a powerful tool that we call try except. So the try except block ideally lets you test a piece of code and catch an error if an error happens. So, and it does this without crashing your program. Like right now, when you got this error, it crashed our program immediately. And again, this is just a small example. If it is in a complex program or a bigger program, it's going to crash and it won't carry out many of the other operations that you want to carry out. But with the try except block, the try except block allows you to test out the code and the errors. In case something comes up, or in case an error comes up, it catches that error and it doesn't crash the program, but it tells you that there's an error that has happened. So this is the simple structure of try except. You just say try, then you have a full colon, and in here, this is where you write the code that might cause an error. So I'll just write a statement here that says code that might, cause an error. It should be a double R here. And you'll also have a catch block. And the catch block, this is where now you have code that runs if there is an error. I want you to note that this is the code that runs if there is an error. So this code that might, I'll just add that here, code that might cause an error. So this is the simple syntax of the try except block. And again, this does not mean that you know that your code is going to cause an error. It is just that any code that you write, you ideally, as much as you're going to do everything right, there's a possibility of it causing an error. So whenever you have this, especially when you have some complex logic that you're implementing on your program, there's always that possibility that the complex logic is going to cause an error. So because of that, you'll wrap the entire logic in the try block. Then the catch block is there to execute something that in case that error comes up. So if you were expecting, or you doubted that you might cause a runtime error at some point, then you'll have your catch block. The catch block is going to say maybe there might be a runtime error at some point. There's a way that we're going to extend this, and you're going to see this. So this should be it's supposed to be try, catch, and there's also except. But for now, we're going to just say try except. Should be except here. I was talking about except all this time, but yeah. So this is the try except. Except is the one that runs if there's an error. There's also catch. Catch also catches an error, and we're going to also see how that works as we proceed. Now, let's look at a simple example. So our simple example is going to be to just use this try except block that we have here. And what I'm going to do, I'll just remove this comment, or should I maintain it? Okay, I'll just maintain the comment again, just to allow you to, in case you want to, just as a reminder of what you're doing here. So we're going to get a simple input from our user here, and we're going to get a number. So just say input, then we tell our user to enter a number, like that. Then we're going to do just a simple division. So we'll get another variable called result. Then we'll have let's say a variable, we had code a number like 10 divided by a number that a user is going to give us. So as you've already guessed here, the idea here is to catch any error that in case a user tries to divide a number by 0. So we're going to print a statement here. Then this statement is going to just give us the result. So here we're going to have the result. Okay, let me just format it a little bit better here. I'll just say result is, then we're going to have that number there. So this is our try block. And this except block, which is a block that catches the error or tells us what the error is. In this block, the except block, we're going to just print a simple statement. And the statement is going to be like something like, oops. Just like, oops, something went wrong. This O should be lowercase. Something went wrong. So in this case, what you'll notice about this except block, or this is the block where we catch our error. we write code that runs if, in case there's an error, and as you can see, it already tells you that something is wrong, and you're the one who defines this statement. So in this case, it does not crash and print out, the entire error logs that we were seeing earlier, but rather it prints to you a simple statement that lets you know that you made a mistake somewhere. But let's run this to see what that is. So it says enter a number. I enter a number like 5. Then you see it gives me the result to be 0. I need to just add a simple full colon and space right there for formatting. So we run this again, enter a number. I enter 4. You see the result is there. Now let me enter a 0. In case of it crashing and telling me that there's a zero division error, it tells me that something went wrong. So once I see this statement, I'm the one who defined it, I'll go ahead and look at my code again to try and see what mistake did I make at some point, then solve that mistake. So always use specific exceptions whenever you can. You don't want to catch errors blindly. You don't want that case, because if you catch an error blindly, then you didn't really know what you're supposed to do after that. So always try to use exceptions. So here's an example of a specific exception. In this case, this is a zero division error that you can see here. And whenever you're writing your code, in this case, when you're getting input from a user, there's always that expectation that a user is going to probably give us, or rather divide a number by 0. So in that case, you can write another exception here. Just say except, then you're going to write the specific error exception that you expect. So in this case, it's going to be zero division error. That's an exception. Again, there's always this list of exceptions in Python, so you can just refer to the documentation to get this. Sometimes whenever you're writing, you'll get some suggestions from your code editor. But in this case, I'll just print a statement and says, tell the user that they can't divide a number by 0. Say you can't divide by 0. Let me just say by 0 directly. So if you tell the user that they can't divide by 0, we're good there. Then the other thing that you can expect here, in this case, when you're doing these kinds of division, is a case whereby a user gives you an invalid number. So in that case, you give your exception is going to be a value error. So I'll just say value error. So for the value error, you print a statement. I'll just get rid of this comment for now. So you will print a statement that tells the user maybe to enter a valid number. So I'll just say, please enter a valid number, like that. Okay, it should be a full stop, like that. So this is what happens with this error handling. Let me clear this and run the code again. So it says enter a number. Let's try 0. You see, it tells us you can't divide a number by 0. Let's run it again. Then let's give it, for example, a letter like Y, any alphabet that is not a number. Once I hit enter, you see it tells us here, please enter a valid number. So this is the thing about error handling. When you're using the try except block, it's always going to give you some of this exception, specific exception that you can specify for your errors, so that you can get something specific. So again, do not catch an error blindly. Always try to look for these exceptions in such cases. And what you've seen here, value error is one of those, and zero division error is one of those exceptions. So when things go wrong, you don't just guess about how to solve those errors. You need to find a way for you to solve the errors, not guessing. So this is at some point, up to this point, I'm almost certain that you've gotten an error and you've tried to guess how to solve that error. For example, you've just decided to delete all the code and start writing afresh, or you've just blindly tried to add a few things, and that's part of the learning process. But whenever you're getting an error, you don't blindly go and start guessing how to solve the error. You need to sort of dissect that error and do some, like, be surgical about it until you find the right solution, so that you don't end up messing up everything and things that were even working before that. So this is where what you call debugging comes in. So this is just the name. Just say debugging, like that. So this is where debugging comes in. To understand debugging, It's quite an interesting way in terms of like how this word came about. Before I even tell what it means, the term debugging originated from an actual moth, like the actual bug, the moth, and this moth was found inside the Harvard Mark II. So the Harvard Mark II was a computer back in 1947, and this moth was causing the computer to malfunction. So there's this one of the programmers who are working on it was known as Grace Hopper, who is a pioneer in computer programming. You can just look her up, and her team tried to find where the issue was. And while they were trying to look for that issue, they found the month and they removed the month. Then they did a documentation of that. So they documented the event in the computer's logbook and how they were able to remove the bug. So that incident and the subsequent removal of that bug is the one that coined the term debugging. And since then, that is back in 1947, the term debugging has been used to describe the process of finding and fixing errors in computers. So you can go read about the entire issue. Just Google it out. You'll find what it means. But debugging, like I've mentioned, this is the process of finding and fixing errors step by step. So this is when you find an error, you need to debug that error. I'll be using that term all throughout this course. So there are a number of simple debugging tips that you need to for you to just help you out while doing this. To do that, I'll just comment out this code for now so that we can just focus on some code here. So I'm going to write a simple function, and I'll call this function divide, and then this is going to I'll give it some two parameters, a and b. Then it's going to return the division of this. So return, let's say, a divide b, like that. Now, from this program, we already expect again the zero by division error whenever we're working with this program. Now, let's talk about the tips that I've mentioned of debugging. One of the simple debugging tips, and this is what you're going to be applying like till forever, I guess. We use print statements. So far, we've been using print statement to just print out the results of operations and some statements that we want to print out for documentation purposes. But print statements are really powerful just beyond that. So you can always add a print statement to see the value of the variables that you're working with before the error happens, right? So in this case, we are having a divided by b, right? The simple way that you can use a print statement to debug this is you'll just add a simple print statement there, and then we can just use an f string to just format this. Then we'll say something like dividing the first value, which is a, by the second value, which is b. So if you say dividing a by b, when we run this program, and I'm going to call this function, I'll just call divide and give it two values, 2 and 5, like that. And when I run this, you'll see once we run, it says dividing 2 by 5, right? And remember, we just return the value, so I haven't printed it out, that's why you don't see the result. But dividing 2 by 5, whenever you print this statement and when you're running your program, you'll just read through the values. Then that will automatically tell you what kind of operation you're trying to do. And in case you notice a zero in that operation and you know zero is going to cause an error, then that is going to help you out, find the go and fix that error. And again, this is a really simple way to describe this, but you're going to find very complex applications whereby you've written your complex program and it is running, but at some point it starts causing errors, right? And because you have, like you've mentioned, you don't fix errors blindly. You have to be surgical about it and do the entire debugging process. You'll find yourself starting to use the print statement to try and see the results of the operations that you're carrying out, right? So, for example, you are trying to fetch data from some API somewhere, or you're trying to do a certain operation. For example, you're trying to do like some, let's say you're building a simple finance track application, and then you will notice that whenever you run the application, the result that you're getting does not make sense. Like the figures that you're working with, you're getting negative values, but again, the figures just don't make sense because there's an error somewhere. So in that case, in your mind, you already know that this is as a result of how I am doing operations at that certain point. I'm either doing a wrong operation or I'm using wrong values. So what you do is you start, inserting print statements at each of the sections where that error is, or rather each of the sections where you are printing values or trying to do the operations. Then from there, as you keep on running your code, at some point you're going to come about where the error is and fix it, right? So we might encounter some of these cases and use print statement to debug them as we proceed, but that is just a rough idea of one of the tips on debugging, and that is on using a print statement. Apart from debugging, we use what we call trace bugs, right? I'm going to just write this as a comment here. So we use what we call trace bugs, and trace bugs are also just an interesting way of solving this error. So when Python throws an error, what you do is the first thing that you usually obviously do is you carefully read the error message. Then once you've carefully read the error message, the error message is going to tell you where and why the specific error happened. We've seen these cases with divide by zero, all the errors that we've been getting. So that is another example. And with tracebug, as you try and understand the error message more and more, and that is going to happen as a result of getting even more errors, which is why you shouldn't be worried when you get an error. But with the trace bugs, as you get more and more errors, you start understanding why a certain error happens. You start understanding all these things. So it takes a lot of practice for you to just understand fully where what the error is and what the error message is telling you. But this is one of those tips that you can use. Apart from trace bugs, you can also break your code into smaller parts, right? So we've talked about modularity when you're talking about functions. So this is where you just test the small sections and isolate the problem. So, for example, you'll find yourself. Actually, this is sort of an example. As much as these two programs are not kind of related, as you see here, I commented out this part so that I can run this part, right? So this is one way of doing that. I commented out the code in the beginning so that I can run specific lines of code. That is one of the ways that you isolate your code. You just comment out certain parts, you start running each of the other parts one by one until you find out which part causes an error. The other way that you can use is the code editor that you're using. It should be Visual Studio Code, any other code editor that you're using. It usually has a debugger. So, for example, like Visual Studio Code, it lets you set breakpoints and steps in your code. So, for example, in this case, you see, for example, I have this. There's this sort of arrow that you can see here. I can just close this down, and there are usually multiple of them across your code. You can use those as some sort of breakpoints for you to solve your error. But there are many of these. Again, don't get worried too much about it. The more you practice on these errors, the more you understand where the errors are coming from. The other way that you can do is we have, for example, in the part of following the conventions of Python and all. So there's what you call PEP 8, the PEP 8 guideline. So the PEP 8 guideline, this is a guideline that is set up to teach you how to follow, or rather the specific Python conventions that you have to follow. So if you haven't followed a Python convention at a certain point, then it causes you an error. Then that means you haven't followed one of the guidelines of PEP 8, right? So you can go and again look it up. PEP 8 guideline is going to come up, and you can read more about it. But to solve a PEP 8 error, or let's say there's just Python guidelines and syntax errors in general, there's an extension known as Flake 8, like that. So what you do is go to your code editor. In this case, again, I'm sure all of you are using Visual Studio Code. So in the extension section on the left panel, just search Flake 8. It's going to come up, and I want you to install it. It will automatically highlight any errors that you have made in your code, or any Pythonic conventions that you haven't followed. So that is again it on how you can solve your errors. There are many other common mistakes that we end up making, especially if you're starting out, when you're making errors, or rather when you're working with the errors. And this is simple errors. Like an example here, we've been working with the try except block. I'll just uncomment this code for now. You've been working with the try except block. Then you find yourself where you have blank except. So in this case, you just have except like that. So again, if you run this, it's going to run your code, of course, but it's not going to tell you exactly what the error is if you haven't specified the specific error that you sort of expect to happen. So this is one of the mistakes that you can make, and it will be costly because you won't know what error to solve. The other way is whenever you're catching an error, you don't inform the user properly what error they are getting. So in this case, for example, we're using value error, and you immediately tell the user that they need to enter a valid number. This is a message that is descriptive enough for the user. If you don't make your statement a bit more clear, it's going to cause a number of issues. The other way is, for example, you write an except block, but your except block does not do anything. An example is you just write like that, and then you use the pass. So we've seen pass before, this pass keyword. We don't use the pass keyword to do anything else other than as a placeholder, as we're waiting to write the code for that part. So if you do this, your except block basically does nothing, right? So that is also going to cause you an error. Always make sure that you get rid of the pass keyword whenever you're working with your code. Then you can also just forget to actually debug and find the real cause of your program. So either you forget or you're just ignorant about it, but you always need to make sure that you find the root cause of your problem. And if you don't, your problem is just going to go bigger and bigger. It won't go away. Even if you comment out the code, the problem is not going to go away. So always be specific with the errors that you catch. Log the errors if needed using print statements, as you've seen. Then you can also find the underlying issue. Do not just silence that underlying issue by commenting out the code or just getting rid of the entire block that causes an error. Always find and fix the underlying issue. Okay, so now we understand everything about error handling, I believe. But again, with more practice, you're going to understand these errors even more and more. Now, I want us to build a simple project on how you can handle errors in Python. And the challenge is quite simple. I'm going to just allow me to again to comment out all this so that you can go ahead and write the code. I'll also comment this one out. So the simple challenge is try to build a small program that asks users for two numbers. Then from the user, divide these two numbers. Then make sure that it handles the simple cases that we've seen. Make sure that in case a user enters something that is not a number, it handles it. And in case a user tries to divide by zero, it also handles such an error. So from what you've seen before, I'll let you, go and write the entire search code program from scratch. But this is ideally what you've just done at this point here, right? So, but I need you to try it on your own first. So we're catching the errors. Zero division error is going to get when you divide a number by zero. Value error in case you divide with something that is not something that is not a number. Then you insert the try block. The only thing that you need to do at this point is get an input from a user. So get two numbers from a user, two inputs from the user. Try to do the operations, then print out the results. Simple as that. So again, I'm not going to go and write the code. I'll just leave it at this actually for now. So that is basically it on how you can handle errors in Python. I'm sure you've been able to learn a few things here. This is a video that I'd encourage you to always refer back to every time. So always watch it over and over again. It will help you find a way, understand fully how to solve errors effectively. So I'll see you on the next one.